1.5 about histograms, right? Each histogram shows an interval as a bar. The heights are the frequency, so like how often you see them, and the relative frequencies and the values in each interval. And like when's the best time to use a histogram? When you have a large data set. Like if you had a huge amount of data, like a dot plot just isn't going to work very well. It's like too many dots, right? So the best time is when you have a large data set. And these intervals, a lot of people call them bars. They're supposed to be called bins or buckets, you know. I don't have a problem if you call them bars. But here's the big question that almost anyone asks. Like, what's the difference between a histogram and a bar graph? Like, why are they different? First, here's the real rule. You can write this down at the top of your page. Histograms are used for quantitative data, right? You use histograms for quantitative data. So like that's when the data is numbers. Our activity today was about your battery percentage. Those were numbers, right? For quantitative data is a histogram. A bar graph is for categorical data. The bar graphs was like, what's your favorite social media app, like Facebook, Snapchat, that kind of, they were categories. And long story short, it's just the labels that you see on the x-axis. It's the histogram, they're numbers, and there's no spaces in between the bars either. But when they're categories like Facebook, YouTube, Snapchat, they got to put a space in between them. It's kind of weird, but they're basically the same thing. But can you kind of see here, like if this was like people's battery life of their computer in these dots, anything between 0 and 5 on a dot plot, they just like totally stacked up. They put all the bins, like all these guys in one bin right here, so like they just stack them up, and then they say, hey, that's anything between 0 and 5. And all of these dudes right here, those are anything that fell between like 5 and 10 and all that stuff. The real tricky part is where the boundary number is. Like where is this 5? Is he in the left bin right here, or is he in the right bin? When it's on your computer, you can hover over it, and it'll tell you if that 5 counts in this bin or that bin. So histograms. Here, I had this data all put into a spreadsheet that you could like copy and paste. There is one question on your homework today where you're going to have to copy and paste the data, and you would put it into the applet to make a histogram on this. But how do you feel that you would just copy all of these ages? This is the first 45 presidents of the U.S., and the data that they collected was how old were they at time of inauguration. So it's kind of old data because they left off Biden and they left off Trump's second term in that case kind of thing. So it's only the first 45, even though we had 47 presidents. Cool, but it's a little bit of old data. But you see, these are all just numbers that I have highlighted in orange. So they say make a histogram of that data, and I did. I copied and pasted it in there. They told me how wide to make it. They said make these bars 4 wide. So like we were messing around with it on activity, just put 4 in there, it would make it 4 wide. Here's our job. Let's describe the shape. What do you think? How would you call the shape of that graph right there? First, let's go with fairly symmetric. What do you feel? Is it in the ballpark? Could it possibly be fairly symmetric? I think it's okay. It could also possibly be skewed which way? Skewed right. You see how it's tricky on some of these because it's just like, it could be this, it could be that. So either one of those I think would be acceptable. I put slightly skewed right because that's what I felt it was a little bit more. There's a little more data skewed to the right. Sometimes they ask you about if there's any peaks or gaps or anything like that. So this does just have one peak and there are no gaps. And then here's kind of the crappy part of reading a histogram, especially on paper. On the computer, you can hover over it, and it'll tell you like how many things are in the bar, right? But sort of the crappy thing is it says what % of presidents took office before the age of 60. So that's going to mean, like, if I could get a better color here, in this pink one, like everything in these bars right here. Are you kind of with me on those bars right there? Everything before 60. Is it cool that they told you that there's 45 total presidents in this situation, so I know the total, and I just got to count up how many guys are in there, right? So I have done the hard work for us because on the computer, if you hover over the bars, it will tell you the number on the top of them. Are you with me on that? So like there are 2, like if you guys would add these up for me, 2 plus 4 plus 9, plus 11, plus 8. You just like add up all of the presidents that fell in that range right there, and we divide it by 45 because there was 45 total presidents in there. shout out a number when you get it for me. What is 2 plus 4 plus 9 plus 11 plus 8? I got 34. All right, so we'll punch that in. 34 divided by 45. And they say what percent? Round it to the nearest tenth of a percent. So let me snip this out because it's still kind of weird rounding stuff to a percent. So if I snip this guy out, I need to first move the decimal 2 places to the right. So it's going to be like right here, it's 75 point something. Then I need to see if this 5 that I put the box around stays the same or needs to be rounded up. So I got to look to that dude right here, which is like the 4th stinking number over if you didn't move the, you know. So it's like, what do you think, 75.5 or 75.6? 75.6% is what we'll go with on that one. So about 75.6%, which is most of them. Most of the presidents took office before they were 60 years old. You cool with how I found that data? Again, when it's on your computer on the applets, you can hover over the bar and it'll tell you the total at the top. All good? Cool. Next question right here is pretty basic. Burning fuels in power plants emits something called CO2, like carbon dioxide, which may contribute to global warming. So what they did was they measured like the CO2 emissions in different countries all around the world in metric tons per person. It says in what percent of countries did emissions exceed 10 metric tons per person? So here is the metric tons, or the number of countries, I should say, in this situation, and here is the metric tons. It's got to be more than 10. So how do you feel about, like, right here, this blue up and down guy is where 10 would be as a cutoff. So I got to count up all of these dudes over here. The weird thing is you're not counting how many bars. You got to count how high the bar is. So this guy is 1 high, 1, 1, 1. But you see that one right there is 2 units high. If you was to trace him over to the y-axis, there's like 2 in that situation. So 1, 2, 3, 4, 5, 6. Is that cool that there was 6 of them? Out of how many countries are there total? Well, I'll be nice and count them up for you. There are 48 total. 6 out of 48. How would you find that on your homework? You have to count each one of these bars up in that case. But I'm not here to waste your time. You can do that on homework, but there's 48 total. So find that percent right there. 6 divided by 48. Nice clean decimal on that dude, right? So 12.5% sound okay? Cool. I'll let you describe the shape. Go for it, and then we'll talk about it. Tell your neighbor that's sitting next to you also, how would you describe the shape of that graph? You get choices between fairly symmetric, skewed right, skewed left, uniform, bimodal kind of stuff. So see what you think. This one probably has one correct answer, if that makes any sense to you. Like, it can't be like a in between. What are you guys feeling? It's cool if we're still not sure on it, but what are our thoughts? Definitely skewed right. Cool. You don't need to write all the rest of it down. Oh, I guess so. They asked, are there any outliers? You know, you don't have to put down the gaps. Cool. Just forget about the gaps, but there are definitely some gaps. But do you think that these 2 dudes over here may or may not be outliers? I would say it's on the fence for possible due to the fact that they're the farthest right that we have, you know. We'll still have a day, someday, where it's like, yep, those will probably be outliers, but we'll do the math on it. But I would say maybe these like 16 and 17 dudes right here. Where did I get those numbers from? I just kind of took a basic guess that it's not 15 and it's not 18, so it's probably got to be 16 and 17 on that one. What's the variability, though? Variability is fancy for low to high. See if you can get that on there. What's the low? What's the high? Tell somebody near you. What did we get for a low? Low is 0. What's the high? It's actually 17, and I'm glad you said 18, right? But you see how 18 is the biggest number on the chart, right? But like the bar doesn't actually go to that, right? So the number on the right doesn't count on the right side of the bar. So 17 is as big as it gets, which is really, really tricky. They also had us find the center. There will be questions on the homework that'll have you find the center also, and they don't give you like the median in the summary statistics, so you have to count it yourself. So you're cool that there are 48 total like bar entries in the bar, right? How do I find the middle? Divided by 2. What's 48 divided by 2? 24. Then I got to go find where the 24th item falls. How do you feel that 12 of them fall in this first bar? Do the height of it. So there's 12, and then I add 5 more. There's 17 total, like 12 plus 5 is 17. And then 4 more is 21. I still haven't gotten there. Add 5 more. Wouldn't it be in this bar right here in that case? Because that's where the 24th one would have fallen, right? So you have to just count up until you get to the middle. Which bar is it in? So that is in bar 3, right? Which is kind of weird because it's to the right of it. Like this is 1, 2, that's my bad. It's actually bar 4. So even I mess it up. You know what I mean? This is bar 1, 2, 3, 4, 5, 6. So that's bar 4 because it's on the right side of 3. So the center is at 4. It's really, really, really weird. That's why I like our homework program, because if you get it wrong, it's like, oh, it must have been the other way, right? It kind of teaches us how that works. Cool. Questions on that, dude? Let's keep rolling, baby. So certain kinds of tumors that people have tend to reoccur. The following data represents the length of time in months for a tumor to recur after chemotherapy. I hope none of you ever have to go through anything like that, but it does happen to people, right? And sometimes they got to do it more than once. So right here, here's the bar graph, or excuse me, the histogram. What is the shape of this guy? Talk about that with your group. Is it fairly symmetric, skewed right, skewed left, bimodal, or uniform? Those are our choices, right? What do you think? So, I think bimodal, even though it's not exactly the same height, you know, like you'd think that they have to be like 18 and 18, it's way more bimodal than it is like fairly symmetric or skewed right or skewed left. So it's good. We're getting better at that, right? It's just weird stuff. How many members were used in this sample? What would you have to do if they didn't tell you? What would you have to do? Add up all your tops right here. 17 plus 5. 9, 18, and 3. Add all those dudes up. And I don't know because I didn't write it down. What do you guys got? 52? Cool. Which bar would contain the median? What do you do to 52? If there's 52 total, to find the middle, you do what to that bad boy? Cut it in half, right? So we're going to go look for the 26th dude. So if I do 52 divided by 2, I get 26, but that's not the answer. Here in this bar, there's 17 different like items in there, right? Because you see how that's at the top. I didn't get to 26. I add up 5 more. Now I'm at 22, excuse me. Didn't quite get there either. If I add up 9 more, I'd be at 31. Would the 26th item fall in this bar right here? So, yes. So the way we'll write that down is it's in this bar, the 20.8 to 27.2, and it's got these weird parentheses and square brackets. We saw that a little bit last time on last time's homework. Here's what that means. The parenthesis is not included, meaning 20.8 doesn't count in that bar, but the square bracket means it is included. So this is a backwards histogram where they are counting the guy on the right side and not counting the guy on the left side. They go back and forth with that. So, but this is the bar that it fell in. This one, and what a weird name. And then what is the relative frequency for the category of this dude right here? So check it out. How do you feel that this is the bar they're talking about that I've highlighted in orange, this 14.4 to 20.8? Be cool that that's this bar right here. Relative frequency basically means let's find the percent, but not change it to a percent. Let's just do some dividing. So like, how many items are in the orange bar? It's cool that there are 5 of them, right? And we had a total earlier. Didn't we find the total to be 52 total things in there, right? So we will just divide that out. And they want 2 decimal places, but relative frequency means don't move the decimal and change it to a percent, just leave it the decimal. So if we go to 2 decimal places, you see I have to look to the third guy right here to see if it's 5 or larger, which it is. So this 9 has to round up to like a 10 in that case. So the relative frequency is 0.10. 0.10. If they wanted it as a percent, you would call that 10%, right? You would move it 2 places to the right. But relative frequency, leave it as a decimal, and percent, move the decimal. Questions on that? And then lastly, comparing two things. This is kind of complicated, so I want to slow her down a little bit. First, I'll just ask you the question and get your opinion. Remember, opinions are awesome, but the statistics have to back it up. So is it true that people who graduate from high school earn more money than students who don't graduate? Your opinion. High school diploma versus not having a high school diploma and the money you make. Do you think people who have a high school diploma will make more than people who don't? In general. Let me phrase it one more time because a lot of people shook their head no. Graduating high school means you get a diploma, right? Will they make more or less money than people who don't graduate? They will probably make more. Now, there are special circumstances, like totally, don't get me wrong, especially in the YouTube world or the streaming world and stuff, there are people who can make a ton of money and have never graduated high school. Does that kind of make sense? But on average, would you totally agree that you probably will make more money if you graduate high school compared to those who don't? Cool in the game? All right. So, what do you think? Let's describe the shape. Here on top, do you see how they have the word no? What do you think that means? They graduated or did not graduate? So I'm going to put like a non-grad on this because that's how we're going to answer these. Just that's the non-grads up there. And then down here, it says yes, so I'm going to call them a grad. Because to me, yes or no is really weird, right? I'm going to call them a graduate or a non-graduate. Is that kind of cool with you? To make it a little easier to understand. So first, let's describe the non-graduates right here. So what would you think? Fairly symmetric, skewed right, skewed left, bimodal, or uniform? What do you think on the non-grad? Skewed right. How about the graduates? Both are skewed right. Does that sound? So do you see how it says both distributions are blank? So we'll fill in the blank with skewed right. They all have single peaks. Then let's look at the two graphs and see which one you think has outliers, because the way they have the sentence started for us, it says there's some possible high outliers in the blank distribution. So we need to figure out if it's graduates or non-graduate. And I might start calling on people here to see what you think, right? So you look here, do you feel there's any outliers? You look here, do you think there's any outliers? It's still new, so what do you think? So I would say there's some possible high outliers in the graduate distribution, like right there, because they did a graduate. And here's the awesome part. I was like bummed out when I wanted to find the center of these this morning. I was like, oh man, I didn't have the numbers written at the top of the bars or anything like that. I was like, what a pain in the butt. I got to count all these up. And then I said, oh, wait a minute. I don't have to count them up, because look at these numbers on the left. They're not actually frequencies, or like, do you see how they're percents? Are you with me on that? So like, check this out right here. In this bar, how do you feel that it says 30% of these people are high school graduates, make between $0 and $10,000 in a year, right? So if they want the middle, what percent do I have to go to just to find the middle? Half of the data would be at 50%, right? So right here, here's 30% of the data. Are you cool with that? And then right here, isn't this another 20% higher? If you add those together, isn't that where 50% of the data is right there? So you don't have to sit there and count how tall they are, because it tells you what percent. So in this bar is where the graduates are. Can you find that in the top graph? Where is 50% going to fall in that top graph? Which bar? The first one, second one, third one? What do you guys think? Which bar? The first one. Isn't there 60% of the data in that first bar, right? So shouldn't the middle of it be right thinking there? So how did we write it? The graduates, yeah, you can just put the numbers. You don't have to put the sentence. Like, how about just, it was in this second bar right here. So let's put the 10 to 20,000. Let's just put that. Let me just go back right here. Let's do it like this. $10,000 to $20,000. That's where that median was, 1,000. The middle of the data was in this bar. But why did I have to put two boundaries? Because it's the bar, it's between 10,000 and 20,000, right? So it's in that one bar. It's weird. Which bar was this one in? It was in this bar right here, which is $0 to $10,000. So right there, that shows you, like the middle of the data, the graduates are making more money. It's kind of weird data, though. It's like I still don't know too many jobs these days, like when you're out of high school and you've graduated, that are just paying you $10,000 to $20,000. That's minimum wage kind of stuff, you know. So this must be some really old data kind of stuff, right? But it's totally showing that the center of the district is larger for the graduates, the grads, meaning they probably are making more money. If I can get my pen to work. Sorry about that, guys. The grads. Let's go with the variability. I will do the graduates, see if you can get the non-graduates. The graduates goes from 0 to 10. Isn't that this very first bar right here goes from 0 to 10,000? And then the largest bar goes from 140 to 150. You see how I did the low to high, but the weirdest thing about these variability ones is the bars have two boundaries to them, right? The low part of the bar and this one. Can you try that on the non-graduates? What's the low bar to the high bar? You got to kind of trace it down to that x-axis. So the low bar is the same both times, but what's the high bar? Where does that guy go down? Not an easy graph to read. Like, where does that second one go to? Between what and what? You can say it out loud. What do you think? Where this orange guy comes down to? Between 50 and 60. And before we wrap this up, I still would like your opinion. Of all the graphs we've talked about so far, is dot plot still your favorite of which one it is to read data? You know, easier to read. Some have pros and cons. The hardest part about the dang histograms is the double boundaries on the bars, right? You know, that's so weird, right? So let's give homework a shot and see how we do.